let's look at 1.7. Another interesting one. Two identical charged spheres, X and Y, carry charges of plus 2q and minus 6q respectively. Sphere X experiences an electrostatic force F to the right when the distance between their centers is r. The spheres are brought into contact and then returned to their original position. Which one of the following represents the magnitude of the electrostatic force that sphere X experiences now? So let's start with F1, right? Before they are brought together and all that. This will be equals to K, Q1, Q2 divided by R squared. Coulomb's law, right? K is a constant. And then what is Q1? 2Q. And then Y is 6Q. Right? Why am I not saying minus 6q? That is because for Coulomb's law, we are only interested on the magnitude of the charge, right? And then divided by r squared. So this will be 2 multiplied by 6. This will be 12kq divided by r squared, right? And then F2. In F2, they are brought together and then separated. What is going to happen when they're brought together and then separated? So we're going to have Q new, the new charge on the spheres, right? That will be Q1 plus Q2 divided by R squared, right? Greater than 11 y. So Q1, we have 2Q, and then Q2, we have minus 6Q. When you're calculating Q new, you actually have to put the sign in there and then divide it by 2, right? So 2q plus minus 6q, that will be minus 4q, right? Divided by 2, we have minus 2q, right? So now we can say that F2 will be equals to K, Q1, Q2 divided by R squared. So K is a constant, Q1, 2q, Q2, we also have 2q divided by R squared. So q multiplied by 2, that is 4, obviously, kq divided by r squared. So let me show you something. F1 is 12kq divided by r squared. And then F2 is 4kq divided by r squared. Should be easy to see here through just a bit of mathematical manipulation that F2 is equals to 1 divided by 3 F1, right? Because 1 divided by 3 of 12kq divided by r squared will give us 4kq divided by r squared. So the answer here for 1.7 is B.